Use differential to estimate 7.9 to the 1/3 power. The differential estimate is f of a plus dx equals f of a plus dy, where dy is f prime of x dx, which is a differential. First, we need to decide the function na. If it is 1.7 to the 1/3, then we would use the cube root function, or x to the 1/3. If it is 7.9, we would need to decide an a where we can easily evaluate a, where f of a is a to the 1/3, or the cube root of a. There are many a that can be easily evaluated with the cube root. The cube root of 1 is 1. The cube root of 8 is 2. The cube root of 27 is 3. The closest one to 7.9 is a equals 8. And so the a that we will be using is a equals 8 in this case. To find dy, we would need to find f prime of x and then dx. This is the differential notation where we state that f of x, we will use x to the 1/3. F prime of x is therefore 1 over 3 x to the negative 2 over 3, which is 1 over 3 x in the denominator with the positive power 2/3. dy is therefore 1 over 3 x to the 2/3 dx. We evaluate dy at a equals 8 with the dx equals negative 0.1. dx is x minus a. dx is the delta x, and delta x is x minus a. X is 7.9 and a is 8. And so dx, or delta x, is negative 0.1 in this case. 1 over 3, plug in 8 raised to the 2/3 power, and dx is negative 0.1. We evaluate this, and this is the differential, which is the difference between the functional value at x equals 8 and x equals 7.9. This is negative 0.1 over 3, the cube root of 8 squared. It is negative 0.1 over 3, 2 squared, or negative 0.1 over 3 times 4, which is 12. And so this is negative 1 over 10 of 112, or negative 1 over 120. This is delta y, and again, it is the change or the difference between the y when x equals 8 and the y value when x equals 7.9. And so how are we going to use this to estimate the function at 7.9? We use the differential formula. We state that f of a, which is 8 in this case, plus delta x, negative 0.1, equals f of a, which is f of 8, plus the dy that we just found. F of 8 plus negative 0.1 is f of 7.9. F of 7.9 is approximately f of 8 plus dy. Now, we cannot evaluate the cube root of 7.9 easily, but that's why we use the differential. F of 7.9 is the cube root of 7.9, and f of 8, if we plug 8 into the cube root function, we will get 2 easily evaluated, and dy is negative 1 over 120. And so 7.9 to the 1/3 power is approximately 2 minus 1 over 120, which is 1.9917.